So let's do a slightly more complicated example, and I want to use it just to make one other point about this type of function. So we have here the function f of x equals 9x, absolute 9x minus 6 over 10 minus 15x. And we're going to evaluate its left, right, and both sides limit as x approaches 2/3. The significance of the 2/3 is actually just the absolute value expression is equal to 0 at 2/3, which means it's going to change from positive to negative at that point. So what we want to do is try to write this as a case function. Let me just show you one way to do that. So let's see, different color. So let me rewrite f of x a little differently. Let me just factor out some constants. So on the top, let's factor out 3. So that becomes 3 times 3x minus 2 over, on the bottom, I'm going to factor out a 5. So that becomes 5, 2 minus 3x. And this is going to be written, we can write it in a little bit more of a familiar form if I take out another negative on the bottom and write this as 3 absolute 3x minus 2 over negative 5 3x minus 2. So that becomes negative 3/5 times 3x minus 2 over 3x minus 2. Well, we can see now is what this function is going to look like. So we have f of x is going to equal negative 3/5 times this absolute value expression is going to be 3x minus 2 over 3x minus 2. In other words, just 1. So this is going to be negative 3/5 times 1 as long as x is greater than 2/3. How do we know that? Because we're just solving the inequality. 3x minus 2 is greater than 0, 3x is greater than 2, x is greater than 2/3. So that's when the expression inside the absolute value symbol is going to be positive, and we don't have to flip it around. On the other hand, for x is less than negative 2/3, we get 3/5 times, this is going to be negative 3x minus 2 over 3x minus 2, which is negative 3/5 times negative 1 for x is less than 2/3. So that means that f of x is equal to, we're just going to simplify this, it's going to equal negative 3/5 for x greater than 2/3, and it's going to equal positive 3/5 for x less than 2/3. The significance here is that if I graph this function, what I get is, let me just put in here, that's the point 2/3. Here I have, I'm not drawing this to scale at all. This is negative 3/5 and this is positive 3/5. What we can see is that x is equal to negative 3/5 for x greater than 2/3, and it's equal to positive 3/5 for x less than 2/3. So if you look back at the earlier example, where it looked like we always say that the right-hand limit is the positive one and the left-hand limit is the negative one, which might be appealing because the right-hand limit is indicated by that plus sign and the left-hand limit is indicated by a negative sign, you can't really do it that way. You have to understand the algebra of the function, because what we see here is that the right-hand limit, the one that is indicated by the plus sign, is actually going to be negative 3/5, and it's the left-hand limit indicated by the negative sign that is positive 3/5. With that graph drawn, it becomes relatively easy to see what these limits are. We can see that that the limit as x approaches 2/3 from the positive side of f of x is going to equal negative 3/5. B, the limit as x approaches 2/3 from the left side, the negative side of f of x, is equal to positive 3/5. And C, since the left and right limits are not equal to each other, we can say that the limit as x approaches 2/3 itself of f of x does not exist. And that's the answer.